Hello, everyone. Good afternoon. I know it's late and it's the last talk, but I guess I have good things to share with you. So I'll go straight to the point so we can think about some software problems together, okay? Who am I? My name is Emerson. I'm a software engineer since I was a teenager, and I'm working professionally since 1998. So it's about 20 years working as a software engineer, software developer, architect, whatever. And I've worked with a bunch of programming languages, everything you imagine, like COBOL, like Code Fusion, ASP, PHP, Java, Python, Ruby. And today I'm currently working with Elixir and Java and Python most of the time. I live in Rio de Janeiro, and I'm also dad of these two beautiful kids. I'm currently working at OLX. So OLX, we have offices here in São Paulo, and the main office is in Rio de Janeiro. We started the operations in Brazil in 2010, but we are present in more than 40 countries in the world. OLX is a funny company and a lovely place to work. I'm working there for the last 7 months, and I'm really enjoying. And OLX, you can sell almost everything, including your mother-in-law if you want. So 2016, we became the first car selling in Brazil. We sell more than 15 items per minute. And during this talk, at least 400 cell phones will be sold because we sell more than 10 cell phones per minute in our platform. I didn't know that before I came and joined the team, but it's very impressive, and I'm very excited to work with those guys in the product like this. So I will start talking. This talk is about software resilience and how your application behaves when everything goes wrong. So I start talking about the Murphy's Law. This expression comes from the result of a human tolerance test for G-forces done by an American aerospace engineer called Edward A. Murphy in 1948. So in order to be able to carry out this measurement, he built an equipment that recorded the heartbeats and breathing of the pilots. He should present the results. However, the sensors provided no results, zero results. That was because Murphy assistants apparently did some mistakes. Frustrated Murphy said, if this man has any way of making a mistake, he will. So everybody knows this. If anything can go wrong, it will go wrong. It's the major Edward A. Murphy that, as you know, is this guy. Oh, it's an aerospace engineer. It's the best picture I can get from him. So it's just for curiosity. What we have to talk here today is that your software will fail. No matter why, something will went wrong every day, every time. In OLX, we work using the PagerDuty to notify us when something went wrong. So, Murphy is always behind us. When I go into sleep, something pop-ups in my cell phone. Most of the time, I have to take a look and see what we can do and how to recover for the problems. And we are doing today on OLX is like most of the companies are doing the last 5 years, that is splitting a monolith into a microservices architecture. So we are doing the same for the last year there. And microservices evangelists often sell this as something like Moses going to the promised land. So we know that for us, nerds, the promised land is something more like this, of course. And when you are doing this movement, splitting your monolith, into microservices, we have the expectation and the reality. So the expectation is something like this. So this is a well-known picture from the Martin Fowler blog, that you have a single application and you are splitting it into a lot of small services, sometimes deploying to Kubernetes or other container orchestration. And this expectation becomes a reality of a lot of poops, because when you split one application into multiple applications and to continue doing the same thing, you will have a lot of problems, because you have more problems. Because when you are doing distributed computing, you do not have local calls anymore. So instead of calling a component, another class or component in your system, you started doing RPC calls. That is a way more complicated. So you will have lot of errors during this problem of the fallacy of distributed computing. You will have problems with the network, you will have the problems with latency, we have problems with the other system going down. So you will face a lot of problems when you try to communicate from one system to another. And if you have to take a look deeper in this problem, you have this PDF from a guy talking about the problem and going deep into it. And we will talk about this right now. So resilience. Resilience is the ability to keep going and to keep working despite of the problems. So we have a lot of buzzwords about it, but I think the important thing to talk today is to take a look of some scenarios and how to deal with each one. So what's the reality when we are communicating with external services? So you have service A, that is your service, and you want to communicate using HTTP to service B. So this is the happy path. You do an HTTP request, you receive a response that is okay, 200, and success. So in the unhappy path, you will receive an error, for example, 500. So the request will fail. So we have these two scenarios. As we know, the failure scenario has a lot of reasons, and let's think about that. So talking about architectural patterns for stability, we have this book. Who knows this book? Few people. So this book talks a lot of architectural problems of stability and resilience of software. It was released 5 or 6 years ago, I don't know. And last year, they released the second edition with more patterns of stability. But we will not talk about every pattern of this book, but some of them. So I will start about a request cache. So a request cache probably is the simplest pattern of this book, that you have your application and you have a cache storage, could be in the same machine or other machine, whatever. So when you call the external service, before that, you will check the cache. So for example, you do a cache read, and if you didn't find any entries in this cache based on the key you are using, you will do the request. So if the request is success, you will update the cache with a short time to leave. Of course, because it's a cache. And your request is success. And after that, when you do the another communication with the external service, you can read it only from the cache, and you do not need to go to the service. Why is this important? Is with a short time to leave cache, for example, 5 minutes or 10 minutes, or sometimes only a minute or seconds, you avoid overloading the other system. And if you do not overload the other system and that external system or service that you're talking, probably other systems are talking with this service too. They do not have a downtime to you have to deal with this. So you prevent some problems if you do not overload that software. Is one thing that you have to do. Another thing is a request timeout. So if you call an external service and you do not time out from your side, the request will continue in the other side probably forever. And I had to deal sometimes with services that responds in 30 seconds. That is unacceptable nowadays. And I had to deal with problems because the software did not have a timeout from the client side. So I had to wait for the service to time out from their side, and probably I become out of resources in my side because some threads and some other problems that I had to deal because my system became out of resources. So the purpose of the request timeout is to fail fast. And when you fail fast, you do not lock a resource in your side and in the other side too. And we also have the request retry. So the request retry is a simple way when you fail with a timeout or error, you repeat the request. So you can do a retry, and if you receive a 200 OK, it's success. So you can do a simple implementation of this with one retry, or you can do a exponential backoff, retry again, and again, depending on what are you doing. So, and for example, if you do a retry and it fails, so you can think about it if your use case allows you to retry more than one time, or you can only retry one time and then stops. After using these three patterns, you can think about another pattern called circuit breaker. So circuit breaker is a pattern that you avoid, again, overloading the external service you're calling. So, for example, you have a simple state machine that you try to communicate with the other system and or service, and if it fails, you can have a threshold to open the circuit and avoid to make calls. So when you open circuits, you can open for a certain amount of time, for example, 1 minute or 30 seconds, and you allow the other part to recover themselves to be healthy again, then you can start to make calls. So if you want to take a look more deep on this, let's return here. You have this blog post from Martin Fowler. You also have in that book I presented to you, but this blog post is enough to get a start with this if you don't know this pattern. So let's say how it works in practice. So you have your application and you have the state represented in this database here, but it's not a database. It could be a file system, could be a Redis, it could be a memcached, it could be the memory of your server or whatever solution you want. And you have your external service. So say you have to make a call. So you first will check the state. So the circuit state is closed. So when the circuit is closed, you can make the call. So you will make the call and the service return 200 OK. So if your call is success, the circuit remains closed. Otherwise, in the example I will show you right now, if you, for example, receive a timeout or error, the request is failed. So you open the circuit. For example, if you configure the threshold for only one failure, you can configure that your threshold is 3 failures, 5 failures. So in the example for the purpose of this presentation, one is the number for the threshold that you will open the circuit. And then in the next time you want to make that call, the circuit will be open. So you will just fail. So you will not invoke the other service because you are giving the other part time to recover itself and then become healthy again. So you will not overload that system and give them the opportunity to the other team that's taking care of the problem to fix things and become healthy again so you can keep going. And some time passed, for example, 30 seconds, and the circuit state become half open. The half open state, it's when you have the opportunity to make another call and see if the external service is healthy again. So if it's fail again, you will simply open the circuit again and give them more time to recover itself and become healthy again. In the scenario that it's half open and you have a success call, you simply close the circuit and your software, your application will understand that the other part is healthy again and continue make calls to that. So what I presented to now is only architectural pattern for stability, but do not deal what we have to do when the other part fails. For example, the circuit is open, but I'm giving error to my users. It's not acceptable sometimes. So what about business requirements? Nah? Everything I said before help us to deal with software problems, but not business problems. It not addresses how to keep working when some problem happens. So it's what we will talk right now. Say you are owner of a gas station convenience store. It's just an example. What will you do if the cash register is broken? You will close the store? Of course not. Probably you do manual chart, reduce the cell throughput, you will start creating lines, you will figure out some strategy to keep your store working and selling to the customers. So you have to continue to serve your customers. So it's the same with software. I have here a quote from Twitter. It's from 3 years ago, but I got this was a guy cursing a lot on Twitter, as we know, and he was complaining about the problem with our chat system, and that's really a problem. So how we deal with these things when we have some problems with external services or some components that are not critical to our systems, and keep working. For example, in the gas station convenience store, of course, if we have a fire, we have to close the store. But only in special cases we have to close. If we have a problem with the cash register of the bathrooms or something else, probably energy, we can't continue serving our clients. We have to try to figure out. So this book doesn't say too much about how to keep working when you have failures, but Michael says that is up to you, giving your context. So it's from the book that he says that no matter the fallback strategy, it can have an impact on the business of the system, that problem. And therefore, it's essential to invoke the system stakeholders when deciding how to handle calls when the circuit is open. It's in the chapter of circuit breaker. So I will present to you a strategy I've been doing for the last year that is the battery backup or backup battery. So a backup battery provides a power to a system when the primary source of power is unavailable. I got this from Wikipedia, and it's like something like this that we use to charge our cell phones and notebooks when do not have power. And the way it works, it's very simple. So you have your application, you have a battery for this that could be something like a database, a Redis, a file system, or other things. And you have to talk with external service. So when it's okay and success, you can use that response to charge the battery with a long time to live. It's at the first moment you think about it, it seems look like a cache, but it's a way different, and I will show you. And when you receive a timeout or an error, you can check if you have a battery response for the service that you are calling. And if you found this, you give a success. So the cache you use before the request and the backup battery you use after the request if it fails. So in a scenario that you don't have, of course, a cache before and the retry fails and you don't have a backup, of course, you can do nothing. You can only throw an error. But most of the time, it can be good for you. Let us show. Because you can have also an external charge to this battery. For example, collecting data from other systems on another databases and puts inside this battery, not relying on your external HTTP call. And you can async and on batch process populate this battery that, again, could be anything you want. It's just to be a place that you can safe read from this. And it's good if it's in the same machine that you are deploying your application, so you can rely on the same cluster. And if it fails, you can read from that battery, charge it for an external process, not only rely on the request data. So you can use the requested data when it's success to populate this battery backup. And you can also have a batch async process using a charger to put charge in this battery and you can use. So you can use again a file system, database, Erlang and Erlang ATS. I use it for that, or a Redis. I have used these 4 strategies for storage. It was a MySQL, a file system for JSON files, and a Redis and Erlang ATS doing Elixir applications. So just to summarize the difference of battery backup and request cache, that is, a cache is a trusted information storage, and we use it to avoid external service overload. And a backup battery provides power to a system when the primary source power is unavailable. Probably a stale information or sometimes a different information just to serve to your clients. A request cache should have a short time to live, and a battery backup should have a long time to live. We did some implementations that could rely to 1 day or more if the external services is unavailable. Some examples of systems I worked: credit card limit approval, rely on sometimes stale information or information charged. When the system that you have to call is unavailable, you can have some information. If you don't have these things, you will probably have problems when you use your credit card in some machines that are not online all the time. Account information. So I did some software systems that had issues with the account system. So we had to make our backup systems that used some stale information to keep working. Listing offer. So I worked at a system that we have videos offering, and we did a request to a recommendation system, and when the system fails, we have a bunch of videos that we can give to the customers, despite of the recommendation system is working or not. And also video playback authorization. So we rely on the user score when we do not know if the user is allowed to play that video or not. So if a score is higher than a certain threshold, we can authorize the user to play that video, and you do not need to rely on the authorization system is up or down. So I've been doing this battery backup as an architectural stability pattern for the last 5 years. And then, oh, I'm sorry. Something went wrong right here. Oh, sorry. Oh, okay. So I want to talk to you about the lessons learned through these 5 years doing this kind of resilience and stability of software that rely on external services and have to deal with distributed applications. So the first thing is to measure everything. So doesn't matter if you have a Grafana or similar, every time you receive a timeout or you have to retry or you are using a cache information or a backup battery, send them this metric somewhere that you can see in a dashboard. It's very useful to try to detect some problems and try to prevent some fails when the other software you are communicating are overloading. This is a real example of a board, and this blue lines can show us that something was wrong with some system we rely, but we keep working and we can see how good is this. The other thing is, do not rely on external services. Even if this external service is yours, it works in and it's running in different machines, probably in with different databases, and you have always to be suspicious about your external dependencies. Murphy is always looking for opportunities, and it will happen. Problems will happen. And that's because you have these problems with distributed computing. You will also have to be resilient for everything. So find ways, and your users are your target. This is from the same guy. And as we know, happy user is money in pocket, always, 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 and always. And be creative and find solutions. This battery backup strategy is something that I'm thinking about for the last 5 years. I did not write any blog post about this. I'm collecting feedback with people to see what they think about this implementation and how to evolve this. But I have a draft and I will try to publish something later. I don't know yet. I'm just trying to think and evolving this concept. So when we had some problems developing some softwares, we had to be creative and thinking about this solution. Some patterns are cataloged in books and blog posts, and probably you will discover new ones and catalog them and find new ways to develop your solution. And to finish, everybody knows that the buttered toast always face down and the cat never. No? So the buttered cat paradox, who knows, is who knows? Some people knows. So to be clear, it's not against the cats. My mom gave me a female cat when I was 5 years old, and I keep her until I was 21, and she died, unfortunately. So it's just a joke. I love the cats. So let's see what happens if we put the buttered toast in the cat bag and throw the cat to the floor. It has a commercial in the United States from a soda that people try this to get energy to the neighbor. So if the sound happens, I will put now. Do we have sound? Yeah. That's how you create new solutions. You know. So again, nothing against the cats. I love the cats. So if you have any questions, feel free right now, and I will publish these slides in my blog that in at Emerlate is my handle on all social networks. So thank you very much.